Hi, welcome to the August 4th meeting of the Kubernetes VMware User Group. On today's agenda, we're going to have a little bit of intro talk and then a presentation on running a Kubernetes home lab on top of home-hosted VMware infrastructure. This project or this particular topic got initiated because we have a intern this summer, Amar Gandhi, who's joining us from University of Cal Poly Pomona. I hope I said that right, Amar. If I butchered the official designation of your university, jump in and correct me.
Yeah, it's Cal Poly Pomona. That's it.
Okay. And he's been working on a project for hosting a Kubernetes home lab on top of vSphere infrastructure. So with that said, a few things. I just posted a link in the chat to our agenda notes document. So I'd welcome anybody to go there and add your name to the attendees list if you like. And then let me share a screen and just start an intro deck. Okay, what we're going to start with is just, here's the agenda. We'll start with one slide on why you'd want to do a home lab, a couple slides on what you need for this in terms of what do you need to go out and get hardware-wise, software-wise. Then we'll go over a few suggestions of useful services. Some of them are essentially mandatory, things like you probably want some source of authentication if you might be supporting multiple users, or even if you're one user and you want to run services under separate accounts, which is probably a safe and secure way to do things, you might want that. And we'll just go over the services that you might want running on this. Then I'm going to turn it over to Amar, and he's going to demo what he's got so far. The summer isn't over, so we've got some things on the plan that have been completed, some that aren't yet but are underway, and some that we've yet to start. But I'll let Amar cover it. We intend to blog about all these things and have links so that this could be reproduced by others. Then finally, I'm guessing that all the people here maybe people on this Zoom already are running their own home lab. So let's share what we've experiences, recommendations, and maybe even anti-patterns. So why would you want to do a home lab? Well, I think the first reason is that it's a great learning activity. The best way to learn about cloud native tech is to actually get your hands on it and run it, in my experience. And maybe doing it in a home lab is a little more forgiving than playing on your employer's production servers. Second, doing this can provide some useful services for yourself or maybe your family if you're in a household. There are services out there that are cloud hosted. Many of them claim, at least in the marketing materials, that they're quote free, but there's an adage that if the product is free, maybe you're the product. In other words, some of these free services are basically mining your data and using them for search engine ad placement, things like that. And maybe doing this might allow you to regain some level of privacy if you can host the media on your own storage that you own. Finally, there is some level of protection here if you choose to do things like, say, home automation, that outsourcing that to a public cloud exposes you to outages of the service, your internet connection. And on a longer term, sad to say, there has been a history of people maybe not making enough money or getting acquired and shutting down these services. I personally had my music collection up on Google Music for a while. They retired it. There have been several cycles of popular photo sharing apps that have been internet hosted that have come and gone. And the bottom line is you and your data may be quite likely to outlive any of these so-called free services or even the paid services. I think as many as half the internet hosted home automation services have disappeared over the course of the last 5 or 10 years, for example. Now, there are downsides of hosting your own. First of all, you have to host some hardware to run it on. So, and that hardware costs money, it uses power, it takes space. And some of these claim to be silent, but some of the others can produce a fair amount of noise. Then you'll need to put time into this. You know, it isn't just spend some money and the stuff maintains itself. It's no different from enterprise IT. And the fact is, if you look at this first bullet, the learning opportunity, well, maybe the fact that you need to put time into this could be viewed as a plus, because I suspect you'll be learning things that will be useful in your career if you work in the IT business as you run your own home lab. So what do you need to do this? Well, first of all, you need a firewall and router. You might already have that. In fact, I guess if you're joining this Zoom and you're work from home, you pretty much do. Well, I guess you could be using your phone, but I think this is kind of obvious, but you might need a more full-featured firewall router than just buying, you know, the cheapest consumer grade router at Best Buy. I would contend that if you're going to do this, standing up a Kubernetes cluster, whether on vSphere or not, that you at least want to get to the point where you can run VLANs and multiple subnets. Some of those cheap consumer grade routers either aren't up to it, or the interfaces for doing such a thing are sort of off the beaten path and not well documented. My personal home lab is using an open source firewall router called pfSense that runs on the FreeBSD OS. There's a few others. We'll get into the options on a slide coming up, but you basically need something like this. If you do your own, you go out and buy an x86 host, or maybe you, if you're a hobbyist, you might have an old PC laying around, because this doesn't take much. I mean, you can run it on a couple CPU cores, 4 gig of RAM, no problem. The toughest ask here is this works better if you have a box that has 2 Ethernet ports. And if you live in a place where you can get gigabit Ethernet, you want those 2 Ethernet ports to be gigabit. In addition to that router, if it doesn't have multiple ports, you want to have a network switch with VLAN support. Amar is going to show you his. He's got a 5-port. So this could be something that goes for less than $20, but you do need one. You do need hardware for your ESXi host. You have 2 routes you can go there, buy something new. If you're on a budget, typically found in households I'm familiar with, you know, you're going to be cost constrained. There are Intel NUCs. There's a thing called a seed reserver out of China. I have an older model than the reserver that I'm happy with. It's a little lower cost than an Intel NUC, and either of those I suspect will start at $500 and go up depending on how much memory storage you put in it. A perhaps cheaper option is to get a used server. At least where I live in Los Angeles, those can be found quite cheap, because a lot of places and orgs have been in the process of moving hosted servers up to public clouds. So they are retiring equipment that they have been hosting in co-location services. Los Angeles is perhaps an outlier, but these colo things, I believe there's 17 of them located in Los Angeles. And I found that if you are a cheapskate, which I'll admit to, if you go to one of these colos at the end of a month, or particularly at the end of a quarter, when people are letting their leased racks go out of service, you will find that these people are retiring equipment that they basically need to get rid of. And I found older Dell rack mount servers here for under $100. They pull all the disks for obvious reasons because they're not going to give you their data, but they can be quite inexpensive. If you get older models, the $100 one, they're probably quite old, and they might need a little tweaking because perhaps they've fallen off the VMware supported list for vSphere. There are some tweaks in there that one of the more infamous ones for home labs is the allow legacy CPUs. The situation is that at some point, VMware doesn't want to host an infinite number of permutations in their test and QA program. So they drop the older ones off the list. Kind of hardware that's older than 5 years becomes something where you better check that it's on the supported list. But there's a gray area where things aren't supported, but they still do run. In other words, the vSphere 7 still has the drivers for them. And that's kind of the thing I'm running. And it is the thing that Amar will be demoing. We're both running on these Dell 710 series devices. And like I say, you could, I think you could get those for about half the price of going Nook. But you have to have a situation where you're willing to put up with primarily, I think, the noise and size. They actually, I've been surprised at how low they are at power consumption, frankly, because you'd think that these big servers would use a lot, but they tend to have very high efficiency power supplies that don't use power if you're not running big loads on them. And I've found that these things can get down to just a little over 200 watts, which surprised me when I first put one in and measured it. In the optional hardware category, I've added a Raspberry Pi or another physical host because it turns out if you're doing things like home automation or things using software to find radios that physically plug into a box, one option is to use a cheap device like a Pi to plug them in. And then there's usually going to be software that converts that IO to an IP connection where you can consume it on things hosted on Kubernetes or in VMs. And the reason you might want to do this is that getting physical access to IO from a VM, and particularly from Kubernetes, is generally going to involve hard configuration of those mappings that some would argue is also a security exposure. So in a real production environment outside the home, these are often discouraged, and I would avoid it even in my home. There's just more abstraction layers you've got to pierce. You might have to put things in containers or Kubernetes in privileged modes that are not best security practices. And if you're looking at this as the learning experience, learning how to get your IO in a way that maintains security is, in my mind, something you want to learn anyway. So that's the route I went. And frankly, the cost of a Pi isn't that significant. So just throw it down there for your physical IO would be my recommendation. Finally, you do need some storage here. You could get an ESXi host if it's a rack mount that has a lot of storage, but another option is to have ESXi and vSphere consume external shared storage. So you might want to consider either a storage appliance, or once again, this is analogous to running on, shrink wrap hardware and spending money for new stuff. There are plenty of open source storage appliance software projects. I happen to use Open Media Vault, and you can run Open Media Vault on bare metal. Now, if you got a pretty capable ESXi host that had a lot of storage slots where you could put disks in your ESXi host, you also have the option of running something like Open Media Vault as a VM and republishing that storage. Open Media Vault, for example, will republish the disk drives as NFS, SMB, and S3, potentially all simultaneously. So you do need to think about storage, but there are various options to get there. What do you need for software? Well, if you elect to run your own open source firewall, you need that. I use pfSense. There's another one that I believe is very similar called OPNsense. It forked off of pfSense. Both of them are essentially GUIs on top of the PF project that is under OpenBSD. And they are very capable firewalls. And I think that if you compare them to commercial offerings, they're actually competitive with those. And if you're not going the route of a very high-end consumer router firewall, you'd have that. And technically, you can deploy that as a VM talking to a managed switch, but I would prefer getting some form of cheap white box x86 and just hosting it on that, just because for troubleshooting and home internet service, there's less dependencies and stuff that has to boot up. You know, if you run it as a VM under ESX and something goes wrong with the network, it might prevent the ESX boot up. So I just personally sleep better at night if that firewall router is on its own dedicated bare metal. And the bare metal doesn't take much. You know, a couple of cores, couple of gigabit Ethernet ports, and you're good. And I've been doing home stuff long enough that I can use like old retired desktop PCs for something like that. Amar's running on an old motherboard that came off of eBay and was purchased for $25. So there are some people who, I don't know, there's a huge number of YouTube videos on repurposing things like cheap desktop servers and things for running these software firewalls. So I think you could get that on the air for $100, something maybe even less money than buying a high-end consumer router. You do need ESXi and vCenter for what we're talking about here. And if you look at normal commercial license prices, it could be discouraging. There is the VMUG Advantage program that gets you have to maintain your VMUG membership, which is paid, but you'll get licenses to many VMware products for about $200 a year. You could go the 60-day trial license. Obviously, that ends at 60 days. As a VMware employee who gets my paycheck from somewhere based on license sales, I am never going to tell you that you could be a mega cheapskate and terminate your trial and just do another one. If you have work in the industry, maybe there's even a way to get your employer to buy your license under the auspices of being a learning experience. So you've got a few options there. I already covered the storage software licenses. There's Open Media Vault. I know there's a whole camp that prefers the ZFS varieties, and I think there's a couple others like that, but I've never used them myself, but I've heard good things about them. You do want some sort of an authentication source, in my opinion. You could go with hard-coded identities and passwords all over, but I think getting an LDAP on the air would be something that would be, once again, a great learning experience, plus you can really use it. There's literally the Open LDAP project. I think Amar has commissioned Free IPA, I think is the one he's using, but he can talk about it. And there's a few options for those. If you're doing those IO collection things like home automation with Z-Wave, there's specialized apps for that. We'll get to them. You may want to run your own container registry for a situation where you're cold rebooting and not wanting to pull things all the way from Docker Hub, kind of even, what they call in on-prem an air gap scenario. So I don't know, if you've got the CPU resources and storage for it, I would personally maybe look at running my own Harbor image registry, which can host container images as well as Helm charts. Once again, you'd learn a lot about it by getting one on the air. You need a Kubernetes. And what we're talking about here, Amar is using a community edition of Tanzu, but this should work with any distro. If you wanted to use K3S, MicroK8s, or OKD, whatever, it should work. We're not today, we're not doing anything that couldn't be reproduced on any conformant Kubernetes. And then there's the apps and services you choose to run. So what apps would these be? Well, in infra, I think I'd contend you're going to end up running either a Docker container engine or Podman. Either should work. Docker Compose is useful when you're running multiple containerized apps on bare metal. I find Portainer, and there's a community edition that, to be useful to remote manage these. Like if you put these in a Pi that's headless. The LDAP source, I already talked about, Open LDAP, Free IPA, there's Authentic, there's a number of them. We actually investigated a number of these, we meaning Amar and I, and a lot of them are not, vSphere itself is not happy with. So you have to be careful. We found that a few of them out there in the open source arena couldn't be made to work with vSphere because their LDAP schema didn't have aspects that vSphere was happy with. vSphere started its life as using a Microsoft Active Directory. And when Active Directory is in LDAP mode, there are certain aspects of the schema that are there. And vSphere, for whatever reason, is dependent on those aspects. You can find some knowledge base articles on it. But the bottom line is, if you don't go the route of proven LDAPs, you might have a science experiment on your hands to get it to work. But there are at least a few out there that work. If you do home automation, the C-Wave converts a USB Z-Wave radio interface to the MQTT protocol. You can route that over the network. And when you do so, the open source Mosquito broker is a convenient way to have the Z-Wave routing go to a destination that can be consumed elsewhere. And you'll find in the home automation arena that MQTT is a very popular, well-beaten path on getting IO from not just Z-Wave devices, but weather monitors and all kinds of things into a spot where it can be consumed by multiple apps. So the Mosquito broker can prove to be useful if you elect to deploy home automation. Some vSphere tools that are just generically useful, not just for homelab, but in general, are PowerShell, GoVMami, GoVC. The latter two are more useful when you combine Kubernetes with vSphere and want to manipulate storage, persistent volumes and things. So pretty easy to throw those up on a VM. Some home away services that we're doing in Amar's summer internship project. Home Assistant is an open source, free home automation that could be run entirely air gapped as long as you're content with monitoring and consuming things in the home, but it can also be exposed out the internet to connect to your own mobile devices. Nextcloud is an interesting project that is sort of like Office 365 or the Google Suite for hosting office productivity apps like word processing, spreadsheets, slide software on your own storage. And the apps in that stack, they have a whole plugin infrastructure, but I believe that the most popular plugin for the office productivity is based on LibreOffice. and you can stand it up on your own server, and then you can actually consume it by opening up a port on the internet and installing client apps on mobile devices like phones, Windows and Mac laptops, etc. Plex is a media entertainment app, so it can host in Plex itself is free software, but it is not open source, but it implements open protocols for media sharing, like DLNA, I think is the acronym, and I forget what it stands for. But you can stand up MP4 movies, MP3 music on your own storage, use it throughout the house from multiple devices, and Plex plugins are built into most of your smart set-top boxes and televisions, in my experience. And as an option, you can start software sidebar to this that will share it over the internet, so that you could play your music collection while driving in your car with a cell phone connection, for example. Just a generic tool would be something like an EFK stack. There's also Elk stack is another one. This is a logging stack that if you start running a lot of services, you ought to be concerned about capturing the logs for it to help you out should something go wrong. Final subject, how do you expose things for out-of-home use safely? Well, if you're running it at the Kubernetes layer, the Kubernetes way of doing this is a load balancer. KubeVip, MetalLB, there's various open source load balancer options. Then ingress is popular on something like a public cloud where they charge you for a public facing IP and you want to multiplex it because you might be paying 20 bucks a month for it. So an ingress service on Kubernetes would be a popular thing. Whether you absolutely need it at home or not is debatable. However, you do have a limited number of ports and probably one IP exposed on your service that you get from your internet service provider, so it might make sense. There are some other, when you expose it, you can do NAT, but an interesting thing Amar and I discovered are these Cloudflare Argo tunnels, and they will let you get, I believe, 5 of these tunnels on a free account. And it's a way where you load an agent at home, it connects to Cloudflare, and then they expose it on their servers that are likely to be far more capable than whenever you're standing up at home. And you don't need to use that. And they're pretty easy to do. They're quite lightweight. I was actually able to get one of these running in a Raspberry Pi bare metal, and it wasn't even a Pi 4. It was an older 1 gigabyte model. So these Argo tunnels are actually pretty cool tech. Another option is that pfSense and other software router firewalls can host an inbound VPN. So you would have to log into this to use it from outside the home. It arguably might be a safer thing if you protected this VPN with both pre-installed client certs and passwords. But it's a bit of a nuisance if you share it family-wide. However, it is an option. So at this time, I am going to stop sharing and turn this over to Amar, and he can talk about what he's been up to.
Oh, sure. All right, so I've got a demo that I can show off right now, and yeah, I think I'll just share my screen and show you guys that. All right, so this is a little demo that I made for my poster presentation, and it's kind of demonstrating a lot of the different things that Steve just talked about with regards to like home automation, as well as exposing services over the internet to the public, right? And doing so in a safe and secure way. This demo application, basically I'm using some of that, I'm using some of that home automation to control a smart outlet, one of those Wi-Fi connected or a Z-Wave connected outlet, and that's controlling a light in my house. And that light is shining on this like little piece of paper cutout I have of the TCE logo, and I can turn that light on over the internet. And in a couple of seconds, we'll see this video stream get updated. And yeah, you can see it right here, where now the TCE logo is lit up. And you can actually go to this website right now. It is publicly available. So if you go to light.acgandhi, that's acgandhi.com, you can go to this website, you can toggle a light that's in my house. But I'd like to talk a little bit about the whole system setup. So kind of pulling back the curtain here. And if I just zoom in on this little diagram that I made of the whole setup, so you can see we've got a couple different, I guess like you could call them workers or services that we're running inside of Kubernetes, and some stuff we're running inside of a Raspberry Pi. And that's connecting to some stuff on the internet, and then that's finally exposing both the streaming video as well as an API and the website to this website right here. So to handle the actual video stream, I've got an IP camera, and I can show that in one of my slides here. So this is like a little picture of the whole setup. You've got the camera is facing on the piece of paper and the light that's controlled by the smart outlet. Yeah, see, I think someone's tried to turn the light on and off, so you can see it flickering a little here. But yeah, so we've got the camera facing the light, and that light is controlled by the smart outlet, and that's communicating over Z-Wave here to a little USB fob, and that Z-Wave USB fob is plugged into a Raspberry Pi, and that Raspberry Pi inside of a Docker container is running a service called Z-Wave JS to MQTT. This is like an open source. It communicates with Z-Wave devices, right, and then publishes or subscribes to topics on MQTT, and is able to allow other allow other computers connected to the same MQTT broker to either control the smart switch or to query different parameters about it. Oh god, I really gotta move this. Yeah, either control the smart switch or query different parameters about it, like the current power consumption or the current status, whether it's turned on or off. Now that MQTT broker connected to it, I've got a little Python API that I made, so it's just a little fast API application. And that Python API is exposed to the internet over one of those Argo tunnels that Steve mentioned earlier. And it's exposed on the domain liapi.acgandhi.com. So if we look here as an example at the network tab on Chrome, and let's just say I hit the update button here. Okay, right now it's just getting kind of spammed with the Twitch stream, but yeah, okay, we can see one of these requests that's being made to the Argo tunnel. And here you can see the address that it's using. This is the address of Cloudflare's Argo tunnel, right? So this is not my home IP address, right? So I'm not exposing something, punching a hole through NAT. Let me get back over here. So we've got that Python API exposed through the Argo tunnel. And then this website itself is being hosted on Nginx, and that's also running inside of Kubernetes. And yeah, so it's just built static HTML and JavaScript files, and those are being proxied through Cloudflare's CDN, and that's being exposed at light.acgandhi.com, which is this domain. And finally, for the video stream itself, we have that IP camera, which we saw on the slides over here. And that one is streaming out to the network via RTSP, the real-time streaming protocol. And we, inside of Kubernetes, we're running FFmpeg, and that's converting the RTSP stream to an RTMP stream, which we can then stream to twitch.tv. So this live stream is not being hosted by me because running streaming video out of a very limited upload speeds on a home internet connection is rather difficult. So instead, we only have one connection to twitch.tv, and we're kind of using Twitch's servers as almost like a CDN for streaming video. And that Twitch video gets embedded inside of the website, and that's how we see all the different components of the website, from the buttons themselves that are making API calls to this Python API running inside of Kubernetes, the website, all the HTML, the CSS, the JavaScript that's being hosted out of Nginx running in Kubernetes, and finally the video stream, which is a connection made by FFmpeg running in Kubernetes, going to twitch.tv, and then being embedded into the site. So I hope that gave a kind of explanation of how this whole demo site is working, and a bunch of different things that we're running in Kubernetes, as well as some home automation that we're doing on the Raspberry Pi. Now, if I go over to this here, this is Home Assistant, and this is on a local IP address, right? Here I can see the Home Assistant dashboard, and I can look at the current power consumption of the light, as well as the current status and the historical energy usage of the light. So you can see that in all the time that this outlet has been plugged in, it has used 0.171 kilowatt hours. And we can see that someone just toggled the light, so the state went off. So that's actually really good. And we saw that the power consumption dropped down to 0.
I guess maybe some of our audience is actually playing around with it, but that's good.
Yeah, I think so, and it's really helping the demo here, so I don't have to like tab back over, turn off the light. All right, so over on, if I can get to it, Zoom always blocks the top tabs. Okay, so I've got my blog here, homelab.acgandhi.com. This is also publicly accessible. And you can go over here where I'm basically blogging all of my progress on setting up the home lab. So far we've got 3 posts. We've got a couple more in the pipeline. This first one just introduces the home lab, what it's all about, which I think you got, Steve did a really good job of explaining here in the Zoom meeting. This post 0A focuses on all the hardware and prerequisite software that we needed. And I think Steve also explained, at least in kind of broad detail, a lot of the hardware and software that we're running on, like the Dell R710 server, the 5-port networking switch, the Raspberry Pi, or the some of the software like vSphere or LDAP, right? And finally, post 1 here focuses on deploying Kubernetes. So this is just walking through the full Tanzu installation process. All right, I think that's everything that I have prepared to share today, unless you want me to talk about anything else.
So let's open it up for Q&A for Amar, or anything I talked about, or I know some of you, particularly Scott, run labs yourself. So you're welcome to jump in, and if we missed any ideas or had some bad ones, jump right in and tell us.
No, I think it was an awesome demo, for sure, and great presentation at the beginning. I myself am using some different tools. I'm using Inlets Pro, which is not a free tool, actually developed by a former VMware engineer.
Yeah, Alex Ellis, I believe.
Exactly.
It's not super expensive though, isn't it? Like $5 a month or something. So
it's extremely cheap. It's extremely cheap, yeah, and it's great. The way that it works, and I haven't played with Argo tunnels yet, so I have to try that out from Cloudflare. Yeah. But yeah, I'm running Inlets Pro. I'm doing a bunch of fun stuff there. I'm actually running my home lab. I had an Intel NUC based one. Some of them went bad. So I now have a Raspberry Pi, an 8-node Raspberry Pi ESXi on ARM lab at home running vSAN. which was a fun thing to get it to recognize USB devices as SSDs for the cache layer. But it works. And I have that set up running a forked version of Cluster API vSphere that runs on ARM as well to start playing around with it, which is a lot of fun. I do mostly Kubernetes stuff, though, in the lab, but do it with ESXi and ARM. And then I also have deployed VRA on an Intel NUC with my vCenter, and then use that to deploy VMs onto my ESXi and ARM home lab, which is fun. So,
yeah, by the way, I'm just looking over the chat. I couldn't read it while I was talking, but Jonathan, I saw you were pointing out you're in Central Texas. So running some of this with heat load is rough. Used to live in Austin myself. What I get away with in LA is I keep those Dell servers in my garage and I put them on the concrete floor, which is basically the average ground temperature, which doesn't get above 70 here, and winter or summer. And they've survived that way for years. And out in the garage, I don't care about the noise.
I recently had to replace a switch in I have a metal shop building. I'm out in the rural, so I've got property. I had to replace a switch because it literally reached, I think it's at 160 degrees Fahrenheit inside that shop building. I'm in about an hour, I'll flip on. I've got my own air conditioning unit inside my office because I will be west facing. So it's a consideration. I'm actually in the middle of working on trying to figure out building up a lab for Kubernetes because my next working certificate is going to be a CKA that I need to work on. So
yeah, those pies might be a way to go, but unfortunately, the whole COVID chip shortage thing made those get, in my mind, they used to be attractive when they were at the original price, but now, I don't know, there's something in my cheapskate nature that just makes me hesitant to pay what those are going for now, if you can even get them.
But I've seen some interesting things done with the pies and running Kubernetes. I had a customer that, several years ago, was working on for a medical environment where they could run Raspberry Pi and connect to it via the AirWatch solution. But then they were running a Docker instance inside there to do data collection using those containers for their medical devices in a chair. And so they could display games, internet, etc. for the patients, change out also to log in for a nurse or other technician, and then also collect the diagnostics there and then feed that back up in both and some of it was always online and other parts were disconnected, like the data collection would do a data dump out of the container. And then bundle all those up and upload them. So it's really kind of an interesting thought, is because what they were going to do is they were to take a Pi and a custom image and have actually a fabricator create their own Raspberry Pi with custom connectors on it for their medical devices. So
yeah, some of the things
kind of cool for embedded.
I have a side role in Kubernetes in the CNCF of being a lead in the IoT Edge working group. And one of the issues with Pis that they're nice for hobbyists, maybe for home and controlled environment, but I'm aware of a lot of industrial projects that either as a proof of concept or maybe somebody thinking it was production without doing all their homework tried to go put them out there in volume. In production. And one of the aspects, particularly of the older models, is that the flash storage in those SD cards just does not hold up. It's pretty much that if you put 100 of them out there for a year, It's not if you'll have a lot of dead soldiers in the field, but just how many, whether it's all of them or 10%, 20%, but everybody has that happen. And kind of the flash memory that goes into those SD cards and flash drives is the stuff not good enough for long-term enterprise use. You kind of get what you pay for. And the only way to get those to hold up is to put in an NVMe or a SATA interface or something like that and move yourself up to higher price storage. By the time you start putting higher capacity plug-in NICs and storage into a Pi, I personally think it then becomes debatable whether you wouldn't have been better off buying a different piece of hardware from the get-go. The nice thing about it is if you're going to publish about it and give demos and talks on the conference circuit, everybody can get to those Pis, and kind of those other permutations are one-offs that aren't distributed in huge volume, but still.
Yeah, the way this customer was addressing that is that they were having a part of that custom build was actually a chip that actually had flash on it.
Mhm.
So it was basically an NVMe, but it was built in and it was part of their custom fab. And so, yeah, they were going to spend money, but they were looking at about 80,000 devices.
Right.
So it was going to be a production run, and it was going to be part of what their normal cost of doing business was. And it was allowed them to manage, but then also be able to update their data polling piece with a new container when they needed to update that and push that out to production immediately.
By the way, I should have mentioned it, but one way to make your Pi survive and not wear out that SD card, obviously you can put external storage in, but for this Pi with Z-Wave thing, the first thing you do is stop logging on the device, put up a log server, and the log is going to be the primary culprit for wearing it out. In fact, even on ESXIs, the recent editions discouraged use of boot from flash on ESXi, and it's because the logging activity is really what wears out your flash media. And that actually is pretty easily remedied as long as you know the issue is there.
And Pi 4 and its derivatives all have the ability to now start booting from media that's not flash media.
Yeah.
And so that really can up your level of that. So I've got,
although the boot is going to be a read operation,
right?
So it probably isn't going to hurt you as much as that logging. The other thing, by the way, that you don't often find is that I hate to run these things right on the OS. Pretty much everything these days is Docker containerized. So even when you run things on Pi, like that MQTT JS to MQ, the Z-Wave to MQTT, it's available in Docker container, and that's the mainstream way of running it. But Docker itself is capable and eventually will fill up the disk space with its logs because they don't have any log rotation by default. So a key element with doing that is to go in there into the Docker runtime config and put a cap on how much log space will be consumed by Docker itself, or once again, take steps to ensure that those logs aren't even being made on the device and go elsewhere over the network.
Oh, for sure. I think the one thing also that I personally do, I run just the Docker registry container and not Harbor locally.
Mhm.
Harbor takes quite a lot of resources to run. It's got a great UI, it's got great functionality. I just run the Docker container though, Docker registry container, and that gives you, and then I use that as a pull through. So you can actually configure it to do pull through capabilities from Docker Hub. So anything that I pull automatically gets pulled through there, and then it gets cached locally. So that makes
it sounds like a great recommendation. I guess it gets around the potential of Docker rate limiting and things too then.
It does. That's like one of the things that really got a lot of use into Harbor, in even in like public clouds and things like that, was that it was one of the first that supported like pull through caching. And when it did that, one of the things that people were able to do was just configure like a container D in the Kubernetes layer, just configure that to be their pull through. So anytime you're pulling to Docker IO, it's just going to pull from a Harbor project. It caches that. And then, yeah, I still, in my lab at the company I work at, we still hit Docker Hub rate limiting every once in a while. But before, I would usually by about 11:30 in the morning, Docker Hub was blocked for the day. Now it happens maybe once a week and usually towards the end of the day.
Yeah.
So,
and even if your home isn't going to hit the rate limiting, I think many of us have limited outbound internet connectivity. So
yeah.
caching is always smart. And I don't know, I live in a household of geeks that are always, you know, especially when my gamer sons get active, can be sucking down most of the bandwidth anyway. So anything helps.
I just set quality of service and give myself 90% of the bandwidth. The other people in my house don't know how to deal with that. And
one of the
really
things I wanted to point out, like one of the things that I was most surprised at in this exercise of getting this stuff up with Amar this summer was actually this tunneling thing, where for years I've been running things in my home lab and exposing them. But, you know, anytime you do NAT, you worry about it. And the fact is that if you ever got targeted by these people who do denial of service attacks and things, you could argue they're unlikely to target you as a home, but you never know. These tunnels prove to be remarkably easy. And then nobody even knows your home IP. So you know, there's some level of security in that, of popping out on the internet at the tunnel. Cloudflare actually ends up putting a cert in front of it for you. So you can argue you don't even need to go to the route of getting the Let's Encrypt certificates, because through those Argo tunnels, you don't get to necessarily choose all your own aspects of the CA there, but by default, they'll put one up for you. And that was just super convenient. And, you know, I don't think people, for these CDN people, when an IP is there, I don't even know that they ever bother trying to do a denial of service SYN attack on those places, because they've just got so much bandwidth and monitoring that they're never going to be successful. And the Ellis inlets thing, once again, that is probably similar. And as my understanding of what goes on there is, you choose a public cloud provider like AWS, Google, Azure, and you'll pop out of the internet there, and it's hosted in a little VM that gets run. So that maybe gives you a little bit more control over where your point of presence is, and should work the same way with a very lightweight agent that runs on your end. And I'm almost thinking that those things might mean the end of trying to punch these things out through NAT. One limitation of the free Cloudflare is the terms of service say you're not allowed to do media streaming. Whether they enforce it or not, I don't know, but they say, you know, you can put, we're intending the free tier to be for web servers and the like. So that if you're doing an API, it might not work. If you're doing by terms of service, if you were streaming movies, you're violating it. So the inlets might be a better choice for that.
There's also ngrok, which also works pretty well. And ngrok, the nice thing is it works for like any protocol, like Inlets Pro, and both of them work with any protocol and aren't just HTTPS. So you can, I forward SSH to my jump box Raspberry Pi at home over ngrok, and then I can access that from anywhere as well.
Okay. What is ngrok? Is there a service behind that, or is it an open source project or something? I'm not familiar with that.
It's what's their, I think their website is ngrok.something, ngrok.com. So it's a secure tunnel. They do have a paid version, they have a free version. And what's nice about it is they also have a Kubernetes ingress controller that can auto create the tunnels as ingress objects. like Inlets Pro does. Inlets Pro also has a ingress implementation so that you can actually just run your deployment, create an ingress, and it's public. Yay. And what's nice with Inlets Pro is while Inlets does cost money, but it's cheap, is that what's really good is that what was it? Because it is creating that small VM in a cloud, you can, if you're smart and set it up correctly with the cloud you aren't using yourself, let's say you're also using public cloud, most clouds have a free tier, and you can actually stay within that free tier and still expose a lot of applications. Because AWS, Google, you're not, or Azure, you're not using one of them, great, use that. You're within the free tier, you can create multiple tunnels and not have an issue. Have some on Azure, have some on AWS, have some on Google. Just milk the free.
Wow, you could get, and plus you'd be super resilient if you were on multiple public clouds too. I'll have to check that out.
You could be on DigitalOcean. I mean, there's a lot of different integrations, and with the free tiers from all of them, I don't think anyone is running in their home lab enough things they would want to publish that it wouldn't make sense to do that. The one other tool that I do use in home labs that I've used previously that makes a lot of sense with something like this is Guacamole, if you know from the Apache organization. And it basically allows you to create a single portal that you just access through a web browser for any RDP, SSH, and VNC connections. Basically. So one of the things you can do is publish a single tunnel out, which gives you access to all of your internal machines that you're running, whether they be VMs or physical servers, and just use a single tunnel for that. And then because it's running a VM, it tunnels everything to those backend things. And that's completely free, open source, Apache licensed.
Okay, great recommendation. Thanks. We'll look into that.
Yeah.
We're at 12:02, so last call. If somebody's got any parting recommendations, remarks, questions, otherwise we'll call this month's meeting to a close, and thanks for attending. Okay, well, I want to thank Amar for the demo, and even more importantly, the work that went in behind the demo to be able to demo it. And we'll see everybody next month, hopefully. Bye.